Good morning, everybody. Today's workshop is going to focus a little bit more on how do we actually transform the ideas into action at your facilities, how we actually save money. We'll give you some ideas, but what I really wanted to do towards the end of the workshop, we will work through some of the examples from your own audits, or if you have some problems in your facility related to HVAC. Both Trevor Van Erde, who's going to help me out today, and myself would be very pleased to offer suggestions or some sort of answers to your questions towards the end of it. So instead of doing a traditional workshop exercises throughout the workshop, what we will do is we will go through the presentation, we'll go through some ideas. If you have any questions, feel free to ask throughout. And then towards the end, we'll work through either examples that you have in your own audits. Feel free to offer them up, and Trevor and I will work through as an example for everybody. Or you can talk to us individually, or we'll go through the examples that we have prepared for you as well. So hopefully that works for everybody. As I said, feel free to ask questions, feel free to interact. This is meant to be useful for everybody, so feel free to jump in. So let's start. What are we going to talk about today? Of course, we're going to touch at the beginning about programs that we offer our industrial customers. Many of you have come to these workshops on a regular basis now for the last year and a bit. So you will already have heard that, but for those who haven't, I would like to take this opportunity to go quickly through the slides and tell you what we offer to industrial customers and what makes us think we're such experts. Secondly, we will go over what we have learned so far. This is third HVAC-oriented workshop in our series. We have been very fortunate to have most of you attending it, so most of you will have this as a backup information, just to go over it, just to make sure that we got the information correctly from the last time. And then we'll spend quite a bit of time talking about the turning knowledge into action, how we can actually turn what we talk about, formulas, abstract ideas, into actionable items that you can implement in your facilities and save money doing it. And then as the last part, as I said, we'll work through some examples, either yours or Trevor's, and we'll call that a workshop. So Enbridge's DSM program. We've been around for 20 years, so we have been doing this for a long time. We hopefully gain customer trust through our experience and involvement with you. We have worked with many of you directly on a day-to-day basis for years now, and we hope that that experience and that working together was actually translated into trust and mutual understanding of what you need and what we can offer to help you out. Just to make sure, because our process, unlike electrical utility, we don't do a lot of measurement post-implementation. We do a lot of calculations based on hard science, hard engineering rules, but we don't do a lot of post-measurement. So our Ontario Energy Board wants to make sure that we have these calculations done correctly. So we're not just doing calculations blindly. We have a fairly strict auditing process in place, both internally and externally through the third-party auditor that Ontario Energy Board hires to control our calculations, to agree with them. So you can be assured that those calculations, even though they may not be measured by the meter, they're fairly accurate, they're within plus minus 5%, and you guys are actually seeing the savings that we claim that you will see. And this is a little graph that we like to show. I at least like to show, and I know that my team shares that. Many of you have seen it. We start all our process essentially through the knowledge development. We give you information because we believe that without information, you will not actually be able to execute any of your projects. We appreciate the fact that you work very hard with your management. And then when you go and ask for money from your management for some project, you would like to see that happen, and you would like to see actually realize the benefits that you promised. So we give you enough information that you can ask questions before you get into the project. We don't want you to just go and do something because we said it's a good idea. We want you to question us, we want you to ask us questions, and we want you to be cognizant of what kind of projects you want to execute. Second one is what we call opportunity identification, where we work with you to find out through either testing or energy use analysis to find out what is it that your facility can benefit the most from. Because lots of people will do one or the other project, but they will do it a lot of times without actually understanding what is it that their facility needs. So for example, if we talk today on HVAC components of our natural gas usage, we're talking about one component of your overall gas usage. You also have some for the process. Depending on your facility, process consumption can be much higher than seasonal consumption. So why would you worry about HVAC? Why not worry about process and trying to get most benefit for your investment in that area? So we are very upfront, we are very clear on where you can gain the most benefit from that. The third one is, of course, measurement. Even though we don't do post-opportunity measurement, we do, if we need be, if the project justifies it, we will do the measurement, we will choose the right metering methods, and we will suggest that either you install the meters or we install some temporary meters in your facility for natural gas or electricity or water to confirm that our input assumptions are correct. So if we say that there is a 10 gallons per minute flow in the pipe, we will actually install a water meter on the pipe and confirm that that flow is actually what you see. Because again, if the assumptions are not good, no calculation can be good. And we do engineering analysis. We're very fortunate. My team has 8 what we call energy solution consultants in here. And all of them are engineers, professional engineers or engineers by profession. And they're very capable of doing analysis and interpreting data to see what is it that this data that we actually tested or metered, what is that data telling you? A lot of time you will have a bunch of data, you will have a bunch of information, bunch of data points, but nobody will actually know what it means. So our guys are very capable people who can actually sit down with you, go through it with you, and explain to you how your energy is used. And last bit is action and implementation. Unfortunately, that is squarely on you. We cannot help you with that. We offer financial incentives for the projects, but ultimately, action and implementation of the ideas is your role. This is what you do. This is your facility. You're the ultimate owner of it. Why trust us? We have done about 110 million cubic meters of natural gas saved with our customers in our service territory. We also saved more than 20 million kilowatt hours of electricity and over 800,000 cubic meters of water. So those are significant results. But that's only in the 3-year period. We have done many more projects over the 20 years that we're in the business. So you can be assured that we're not somebody who just started this. We have done this for years, and we have been very successful at it. Of course, participating in our programs helps you both reduce your CO2 emissions because you're reducing the natural gas usage or electricity usage, and improves your bottom line. And ultimately, this is what I want. Ultimately, energy saving doesn't matter if you don't save money, because that's what you are measured on. You're not measured on kilowatt hours, you're measured on how much that will have an impact on our bottom line, on our accounting sheets. This is what we want you to do. So what have we learned so far? What did we touch upon in the last few workshops? We said makeup air is expensive. Most of you who have some sort of process in the building, in the facility, will have to have some makeup air. That makeup air is expensive. How expensive? Well, every 1,000 CFM costs you about $1,500 per year. $1,500 per year for every 1,000 CFM. Okay? Doesn't seem much per 1,000 CFM, but given that only one typical mushroom fan will have between 2,000 and 5,000 CFM, that quickly adds up. And given that most of those mushroom fans were installed because you had problems in the summertime with a hot environment and nobody turned them off in the wintertime, adds up really quickly. So we'll go through a couple of examples later on. What does that actually mean? But let's just remember that it is expensive. Let's also remember that volume of makeup air is directly proportional on the exhaust volume your facility has. So controlling that exhaust volume will control makeup air costs. It's not always obvious to think in those terms, but this is exactly what it is. A well-balanced facility will need about the same amount of makeup air as it has exhaust. We also learned about seasonal consumption. We touched upon it before, but we learned that natural gas users in your facility can be split into those that are seasonal, whose usage of natural gas depends on the outdoor temperature and the weather, and those that are process-related, which means those are the users that are pretty much constant throughout the year. Those would be your process ovens, your process boilers, something that's used to make a widget in your facility. We have learned how to distinguish between the two. So if this is the graph, monthly graph of your usage for the natural gas, let's say in June, July, and August, you have no heating. Therefore, if you draw the line right above it, that's going to be your basis for the process load. So you cut it off. This means this is your process load now. Process load times monthly process load times 12 gives you the process load over the year for the facility. And of course, the leftover is your seasonal load. So if your graph looks like this, where process load is fairly low and your seasonal load is fairly high swings like that, you should definitely be looking at HVAC. And by HVAC, I don't necessarily always mean space heating, makeup air, exhaust, process exhaust. Many times you will have ovens on the paint lines, for example, that will use more natural gas in the wintertime because the parts are colder and because the air is colder that you're drawing from outside. But it will be dependent on outdoor temperature. Therefore, it will be a seasonal load. This is why we don't call them HVAC and process load. We call it seasonal load and process load. Of course, if that was the end of it, it would be fairly simple, but it's not. Inside the seasonal load, now we have a makeup air users, we have space heaters, and usually none of your facilities will have one of each. It will typically be 10 makeup air units and 48 space heaters. In addition to any process equipment you may have. I'm showing there only one, but usually you guys have 2 ovens, 3 ovens, 2 boilers, combination of any of those. So therefore, establishing the accurate baseline, how much each one of these units is actually using is very difficult, but it's a crucial part. Because replacing unit heater is very simple, but replacing unit heater to save both energy and your cost is more complex than that. We have also learned that facilities operational hours, consumption of gas and electricity, indoor temperature setback. So if you're not in the facility, you set the temperature of the indoor less than what it is when you're there. And facilities location, heating season, and facility square footage all have an impact on your costs. So I listed there about 7 different factors, 5 of which are within your control. You can actually control them. When you really think about it, the only thing you cannot control is how long you have to have a heating season on, because that depends on the weather outside, and what's your facility square footage. It's really difficult to rebuild a facility every couple of years. So we'll assume that that's fixed. So operational hours, people would think, well, we can't really affect it. Sometimes you cannot. For large users who are 24/7, you cannot. For some smaller users, it may make sense to run a paint line 3 days full out and then shut it down for the other 2 days. It may make sense from the both cost and operational perspective. I know it's hard to convince your people in the facility who run the production that that's the case, but maybe we can help you out build a business case on how much cost there is actually involved in that. And ultimately, when I look at this graph, when we look at arming customer with information, opportunity identification, all the way to action implementation, if you strip our pictures from this, our slant on it, and replace it by this, suddenly this looks like what you've been dealing with all along. This is your basic Six Sigma graph. Lean manufacturing, Kaizen, whichever one you like to use. You control the factors, you define current state, you measure it, you analyze it, you improve on it, and you go back into controlling. So using energy is the same as using your production data. So incorporating energy into your continuous improvement processes will make your energy visible. And once the energy is visible, everybody in your facility, not just you, everybody in your facility will start thinking how they use energy. Be it electricity, be it natural gas, be it water, I don't care. As long as it's energy, it can be controlled. And if you explain that to your production people, they will understand it. This is basics of their production quality control. So if at the end of the shift, if we make 15 parts that are being painted, and we know how much steel we put into those parts, or aluminum, and how much paint powder we put onto those parts, why don't we know how much kilowatt hours or cubic meters of natural gas did we use? There's no reason. Typically, it was too cheap, to be honest, to care. But it's becoming more expensive, and it's more important, we're in a global world. You're competing with a lot of people who are not from Canada. You're competing with a lot of people who know exact costs for their products. So if you estimate the cost of the powder paint and the cubic meters that are used for painting the powder, let's say, shelf on the furniture, you may be pricing yourself out of the marketplace. It is not the same how big the part is, how much cubic meters you use to paint it. So understanding that helps you price your product correctly. Understanding pricing your product correctly helps you being more competitive in the marketplace. This is what we really want. I am not big on saving cubic meters for the sake of saving cubic meters. Saving cubic meters because it's going to make you more competitive, it's going to make your facility stay longer in business. That's what I care about. And my team cares about the same things. So let's talk about turning this knowledge into action now that we went through what we've learned so far. Let's go through a couple of examples. And I like to talk in 3 R's. Reduce, recover, replace. In order here is important. So we'll talk about reduce first. This particular approach to energy savings is way underutilized in our marketplace. I just came back from Europe for a vacation, and I can tell you that energy savings there do not require any government intervention. Energy is so expensive that everybody is saving it, and it's been doing it for years. We're fortunate, but let's not throw away our fortunes. Let's use this as an example when it's early enough and it's not too late to actually make changes. Underutilized because we have always done it this way. Nobody wants to change anything. Nobody wants to say, well, let's try a new setting. In my past life, I have been fortunate enough to move the facility to China. I opened the facility in China. Brand new facility, brand new employees. And if I asked somebody to change a setting, it was in a blown film manufacturing, so in the plastics operation. If I asked somebody to change the set point, it was changed within 20 minutes. There was no argument, there was no committees. Let's try what happens. We need to do that here. We need to do that much more than what we're doing now. Because ultimately, those are no cost or very low cost implementations. What does it take to change the set point? Right? And they're easily reversible. Everybody talks about the risk to production. Well, if the set point of 350 degrees F is not right, put it back to 360 degrees F an hour later. It's okay. You didn't risk that much. And we can help you out estimate what is the potential upside. So you don't go blind. You don't just say, I'm going to change it for the sake of changing. No, I'm going to change it because potential for savings is this much. So why not explore that potential? We have lots of it. I have seen many of your facilities. I've seen many of the facilities of other customers in our service territory. I can tell you for sure that most of the equipment runs very inefficiently today. Because Joe put it at a certain 425-degree setting. Joe retired 5 years ago, and nobody can remember why that setting was there. Not one person in the facility knows. But nobody wants to change it because it's the law. Joe put it there. Okay. So let's explore that. Let's see what can be done. One example of reduction is exhaust. We talked about exhaust, how controlling exhaust controls your makeup air costs. So I'm sure you've heard this. I've heard it from one of my customers, so I'm going to steal it from them, that solution to pollution is dilution. They had a problem with some stuff that there was localized fumes in the facility. So what do? They put a whole bunch of roof fans all around the facility just to get it out. Well, they didn't realize how much impact that's going to have. You have makeup air, blue, and the exhaust in red. So the problem was exhaust was excessive because they want to control localized fumes around the welding facility. Welding was like 1/10 of their surface area in the facility. But they put a bunch of fans up on top. Well, what happens when you have more exhaust than you have makeup air? Air has to come out of somewhere. None of our facilities are hermetically sealed. So air has to come out of somewhere. So it comes through the windows, open shipping doors. How many of you have heard people at the shipping area complaining, I'm cold, it's drafty here? Well, it's drafty because you have too much exhaust, right? So you call your HVAC guy that you worked with for years and years and years. He goes, well, you just have to balance exhaust with the makeup air. I just happen to have a makeup air unit for you that's going to do that. Is this the right approach? How about if we put localized extraction instead? So instead of 10 5,000 CFM fans that are on the roof 200 feet away from the actual source of fumes, you put localized hood at 3,000 CFM above the guy's head. Now you avoid putting the additional makeup air. You're directly avoiding additional investment and cost of operation. $1,500 for every 1,000 CFM, remember. So controlling the volume of exhaust will control your makeup air costs directly. No question about that. Let's make it even better. Let's interlock the makeup air to the exhaust. You don't need makeup air in the usual facility unless you have a significant amount of exhaust. So if the guy is not there, the exhaust doesn't have to run. Therefore, makeup air doesn't have to run for that period of time. Right? Let's put it on programmable thermostat so that when the guy has a 1-hour lunch break, this goes off automatically. Doesn't need to be there. Doesn't need to run. Are those huge savings? No. But controlling the time exhaust is on will, again, control your makeup air costs. And we talked about it's not a huge saving. But look at the example here. We had a 30,000 CFM fan in the area. Auditing to make sure that the indoor air quality is correct because we don't want to endanger your indoor air quality by any of our actions. Thermostat and installation cost $3,500 for that facility, for that area. Savings for 2 hours a day, no more, 2 hours a day in both electricity and natural gas came to this. Payback was 1 year. That was one fan and 2 hours a day. So yeah, these are not big projects. There's no reason not to do them. Because you can probably find $3,000 somewhere in your maintenance budget. You don't even have to ask anybody. Because in 1 year, you will have that money back. And we offered $458 of incentive for that money. So a little better than 10, 15% of the cost. So that payback was even better than that. So no big projects, nothing flashy, no front page, but very valuable. Another one. This one was a little bit more front page. Worked with a customer who had these consumption numbers, January to February. You can see seasonal load. You can see the weekend consumption. And so we talked to them. We said, oh, you must be running 24/7 production. He goes, no, I'm running 24/5. So I went back, I reanalyzed the numbers, and came back. And I was like, no, 24/7. He goes, no, 24/5. I told you last time. Well, so why is it that 24/5 should give you 29% of your time throughout the year being off, Yet 24% of your energy is used in exactly that time. He's like, oh, that's a problem. So we went back, we looked at it. He came back on one of the Sundays that nobody was in. He went back and by himself to take a look at it. Every single makeup air and space heater was on. Full blast. Not one person in the facility. They were using 364,000 cubic meters of gas in those times out of 1.3 million. Significant amount. So what we did is we worked with their vendor, local vendor. This was not canned solution. This was not one of those expensive building automation system solutions. This was vendor that they worked with before who did some of the programming for their interface for their machines. We worked with their electrician who pulled the wires. We installed microprocessor-based facility controller in the middle of the facility. We had zonal controllers, 6 of them throughout the facility. The facility was about 250,000 square feet. We could put it into historian and PC-based user interface that was all done by their local vendor, nothing special. And we even had the internet connection to key people. So if the makeup air was left on the weekend, the maintenance manager and the plant manager would get an email saying, your makeup air is on. Okay. This is what their user interface looked like. They even then included the lighting control as well. So they had the ventilation, heating, and lighting. And we could control zones based on their production lines. So if 4 out of the 6 production line was not operating, 4 out of 6 zones didn't need to operate either. And then we track this consumption and outer temperature just to make sure that we're not skewing the data. This is after implementation. This here is before implementation. The graph still looks like down there today. I checked it the other day. These are significant savings. How significant? $140,000 worth of investment, including, again, audit to make sure this was a unionized facility. They want to make sure that their indoor air quality is not affected, which is fair enough. Design of the system, installation, pulling the wires, the whole shebang. These are the savings. 360,000 cubic meters of natural gas. We actually saved more in the end, but this was the projection that we claimed, and I stuck with it. We saved about 420,000 cubic meters and almost 1 million kilowatt hours per year. The guy had 500 horsepower worth of exhaust fans on the roof that were working 24/7. It's a lot of electricity. So that payback was 0.8 years. So a little larger investment, yeah, but 0.8 years. We gave them $28,000, $30,000 for that, so that reduced that to about half a year payback. You can't do much better than that. And it's significant enough. This went down to their Charlotte headquarters in the United States, into their newsletter, to every facility in North America. To this day, they talk about this project. It didn't affect any of their production. Nowadays, they're actually expanding on that. They're controlling individual zones. They're controlling individual lines. But all of that started with this project, which on its own is very valuable. So these are the things that you should be keeping in mind when you talk about, do I have room for improvement in my exhaust usage? Have your operating hours changed? How many of you have lost capacity and went from 24/7 to 24/5? I bet you lots of you. I know my facility where I used to work, we went like that. I mean, some of you went to 16/5, but I bet you that all of your equipment runs 24/7. Because if you have any number of makeup air units or exhaust fans on the top, on the roof, that have to be turned on individually at the point of usage, how many maintenance people will go around the roof every Friday and turn them all off? Probably none of you. But if you pull the wires, you don't even have to have building control system. Pull the wires, have one big red button that says turn off exhaust when you leave the facility. You will save energy. This does not have to be complex. You can make it programmable. You can make all sorts of user interfaces. But the basic principle is you have a big red button that says turn off all of this stuff when you leave the facility. Has the process changed? Welding station turned into riveting station, for example. You had lots of exhaust because it was welding. Now you're riveting. You don't need that exhaust. I was at a facility where they had 2 8-foot fans up on top, one of those axial fans that was on the roof. It was building much like this, nothing in it, empty space. We looked up and like, what are those fans doing up there? He goes, oh, I don't know. So he asked. They had a huge welding operation that moved out 5 years ago. Those were still going. We saved huge amounts of money just by turning them off. Different areas run different schedules. For example, if you have distinct areas that have distinct lines that don't run the same production times, hook up the exhaust that's directly above it to the production equipment. So if the production equipment doesn't run, your exhaust doesn't run. Again, it will save you money. It doesn't require any more thinking. As soon as they turn off the equipment for the production, exhaust will go off.